Please work. There we go. All right. I'm going to stand here next to my notes. How many of you have watched at least the week 1 recording that I've posted? Okay, a fair amount. I'll introduce myself and then I'll deal with the first WTF. And then we'll move on from that. My name is Dan Goudreau. If you've watched week 1, you've had my long form introduction. If you haven't watched week 1, well, you didn't get the long form introduction, you get the short version. I am a part-time prof. By part-time, I mean I teach 14 hours a week on top of a 37.5-hour week job. I work full-time for a software development firm. We write software for making signs. Sounds a weird industry, but we work with stuff that a lot of people have never seen, so I see all kinds of neat stuff day to day. Now, I teach what I do for a living. I'm what they call a full-stack web developer. In other words, I write web apps, I write also desktop applications, I administer, design, create, maintain database and database servers. I do the same thing with web servers. I do the whole shooting match. I'm the backup network administrator and my non-stop working guy. So I deal with pretty much everything that has to do with IT. I've been doing it for 20 years. So I've been around the block for a bit. I've seen lots of changes, some for the good, some for the bad, and some was whatever. Like I said, if you've already watched 1 or 2 of my recorded lectures, you'll also realize I don't really teach like some other teachers. I have a very unique style. We'll go with that. I always put some warnings and some caveats. Warning number 1, I will probably offend you. I apologize now. I don't mean to do it on purpose, it just happens. 2, I will not remember your names. It's not because I've lost 4 weeks, it's because I have the name capability retention of a gnat. Now, I never forget a voice, and I never forget a face. I've run into students from 10 years ago, and I recognize them instantly. But I will not remember your names. In actual fact, for you guys, that's a good thing, because I do all my grading completely impartial. If I don't know the name, then I don't know who I'm grading, therefore I treat everyone the same. So for grading, you'll never find someone more impartial than me. Now, because I'm a laid-back guy, there's some things I don't worry about. I don't tend to hunt down for attendance, and well, considering the cluster canonical that you're in right now, I'm recording, right? I gotta watch my language. The cluster situation we're all in right now. I'm not gonna hunt you guys down for attendance because I record my lectures. Thursday night's an odd day for me for recording lectures to be able to get it put up, because most of my recording files, like the raw files, are close to 25 to 30 gigs of file per video. That having been said, normally I get it up within a day or 2. Depends on how good the bandwidth is at home that day. I'm fighting with the teenager. All right, so this is who I am. Now, WTF, okay. Apparently the wheels went off this like a river crossing during Oregon Trail, from what I've been told. And what I've been told is almost nothing. All I know is previous prof gone, Dan, please take a class. I have no idea what you guys have or have not learned. Thus, tonight's lecture is going to be a little weird because I don't know what you've learned. Or not learned, or lack of, yes?
We just start from square 1 and just assume that's the test.
Yeah, the problem is that we've lost 4 weeks.
So wait.
So it's going to be really abridged. Why? Which is where I'm saying those lecture recordings I've put up, please watch them. I'm going to treat, today I'm just going to do a quick cursory overview of lectures 2 and 3. What's going to happen is I'm going to do something that normally I don't try to do, which is teach to the exam. Normally I teach to the exam and then teach more. My goal is to get everybody here that can pass the course to pass the course. That doesn't mean I'm going to give you free points. It just means that there isn't going to be a lot of extra fluff thrown on for shits and giggles. And that's just unfortunate. But in the end, you will learn everything you're supposed to know coming out of this class. Are you guys level 1s or level 2s?
Level 1.
Okay. CET?
Yep. Yeah.
Whew. Makes it a little easier. If you're the CP guys, you'd be doomed. The CP guys have 4 database courses. You guys have 1 you have to take and 1 you can choose to take. which is the level 2 CP course, database course. Sort of. Level 2, level 3-ish. That's the good news. So what's going to happen is tonight I'm going to go through what was in lectures 2 and 3 really quick in the first hour. The first 2 hours. And then the second 2 hours I'm going to crash course some SQL because I have no idea how much SQL guys learned off of the lab teachers. Yeah, sorry, you're going to have to either skip it or walk. Unfortunately, and the other thing you might have noticed if you watched some of my recordings is that I don't jump around very much. I pick a topic for the lecture and I stick to it. So this 2-part lecture tonight's going to be interesting because it's not how I normally do it. Some of the other teachers were doing 1 hour of design, 1 hour of SQL, 1 hour of design, 1 hour of SQL. I covered 40% of the final exam in 3 weeks. Just so you know. So those 3 recordings, weeks 1, 2, and 3, if you watch those, that's over half the final exam.
Where can we find them?
Under recordings on Blackboard. As I posted on the announcements with the link. They're on YouTube, so you don't have to be on the network at the school to watch them.
Thank God.
I finally got permission from Andy, the chair, to actually use YouTube to upload my videos. Which has 2 perks for you guys. One, the audio, I don't sound like Smurf. The service at the school that we use has changed their compression stuff, and I sound like a Smurf. Okay, I sound like this. And it's horrible because you can't understand a word I'm saying. In a minute, I'll give the 2-second crash course of Blackboard where I've put things, but if you've already been exploring, you should know where most of the stuff is. Assignment 1's already been handed out via the lab monitor before I took over the class. There's no way on earth I could get you guys ready to do my version of assignment 1. So what's going to happen is you're going to do assignment 1, the one you've been given, since you've been all hopefully working on it. And I will try to backfill as much of it as I humanly can. And I will be posting links to my lectures from my Monday section for you guys also, so that you have the less abridged version for some of the topics if you choose to watch it. But essentially at this point, if you want to have a chance of succeeding, just being completely honest, at least watch week 2 and week 3 recordings that are on Blackboard. Do the hybrids, because the exam covers the hybrids, essentially. You do the hybrids, the way they work is you get 2 shots at it, the system keeps the best grade. The questions come out of a random pool. Thus, you do it again, it's not going to be the same test. The test basically gives you a chapter, and as you'll see, some of the hybrids actually have PDFs of chapters on there, because, as you all know, we had no textbook for 3 weeks. Or some of you may know we had no textbook for 3 weeks. They just went gone. Okay. Yes?
You said some of the lectures are abridged, some are...
No, the ones I'm going to be doing for you guys are going to be abridged for the next little bit.
Okay.
No, have a choice. When I was asked to take this on, for example, I sent out the announcement that next week, I can't lecture next week because I had a prior commitment to a charity that I had agreed to 2 months ago. And they have 25 wheelchairs and 3 volunteers. I'm one of the 3 volunteers. And at that point in time, it's sort of like I can't find someone to replace me. And my wife's the vice president of that thing, so I got to balance my needs at school and my needs at home. And, so that's why today we're getting the double long lecture. It's going to make up for next week's lecture.
So there will be no lecture?
There is no lecture, but the way I'm going to say it is if you haven't watched my videos yet from my other section, section 300, next week's a good time to do it. At least it'll get you maybe the last one you haven't caught. They're about an hour, 20 minutes each. So realistically, if you're going to, yes?
Where will we find the videos?
On Blackboard, under the link that says recording. In a moment, I will be showing you those on the screen. That's the second time I've said it. Okay, that's this. That's the WTF. Naming conventions. I will be posting them on Blackboard. My naming conventions are very, very strict. I'm not sure what naming conventions you've been told to use. I'll be sending out a note to the lab folks to make sure they follow. Those of you that have Howard, he's had me as a lecturer before. He and I work well together. You know, we've had coffee at the mall together. So, and I've worked with Kumari before also, so we should all be able to be copacetic as best as we can. But essentially, my naming conventions are everything's lowercase, there are no spaces, and everything is you separate keyword, like you separate object names with underscores. For those of you that may know this phrase, you guys, when you're learning your naming conventions for programming, you're using camel case, right? This is called snake case. That's just what it's called, snake case, right? I'll put them up on the board in a minute, but I just want to finish going through this little list. Okay, what the hell is happening? No, we'll change that to an H. What the hell's happening? Essentially, like I already pretty much explained what's going to happen. The lab monitors have already agreed that starting with lab 5, they're going to switch to my lab set. Okay? They've both received PDFs of my lab document. I don't have control over their lab areas. But I'm hoping they will distribute the PDF to you guys, but I will also put it on this Blackboard. I've just been running around like crazy trying to get caught up. Because we normally have 3 weeks to prep for a class. I've had 4 working days. So it's a little interesting trying to find the right pieces for you guys. Essentially, Lab 5 is a normalization exercise. It's a 2-part exercise. It's literally a Word document that you submit, so there's no database work. It gives you guys a little break away from the clicking and the typing. And then after that, believe it or not, it's pure SQL pretty much all the way through to the end. So hopefully we can just get everybody to where they need to be. There is going to be a practical exam as well as the regular written exam, which I don't know if you guys know about that or not. There's the written exam, which is worth 20%, and then a practical exam, which is administered in lab, worth 20%. I'm in the middle of negotiating with powers that be exactly what that exam is going to look like for you guys. If it's like with the way they're basing it on my old ones, so it should be good, not overly cruel. Okay, going forward, the plan going forward is today I'm going to crash course through lectures 2 and 3, and then we're going to do some SQL, and then we should be at the point where you guys are almost where my guys are. There'll be a lot of SQL going forward. Essentially, that's where I'm at. I do all the theory at the beginning, and then I do all the practical at the end, so that you guys have something that's less stressful. Eh? You were the other way around? Yeah, of course they were. Let's make you work with the stuff and not know what you're working with. Here's a grenade. We're not going to tell you what it does, but here you can pull the pin. Right? Essentially, I have a very different way of looking at it. So therefore, I'm going to be kind of piggybacking a few odd lectures here and there. Hopefully it's going to go well.
You said after lab 5 you're going to use my labs. Is that
your
labs?
My labs.
Your labs. Okay.
If I can get caught up by next week, as in between this recording and you guys watch my previous recordings, what I'm going to do is the lecture after the next week, so though I can't be here next week, the one after that, I'll treat it as a QA class for the first half. So here's your homework for the next 2 weeks. If you haven't watched the videos, watch them. Do the hybrids. Because the day after the hybrids, which are due mouse, hello mouse. Hybrids are due on the 26th, so that's 3 hybrids. That's basically 3 chapters you are to read, 3 sections of chapters you are to read, and 3 tests, quizzes you are to do. Because that's when your first real test is going to be, is the day after the hybrids. The hybrids' basic purpose in life is to get you ready for the test and the exam. Technically, the hybrids and the test should get you about 90% ready for the written exam. So if you do what the hybrids tell you to do and you read, and you do the tests, and you do okay, theoretically, you should do fine on the exam. All right, now I'm going to go over my naming conventions, and I'm going to be sending that off to the lab monitors. But I think for the first assignment, you can just go with whatever you've been using, because they're the ones, you know, that handed out the assignment. That was prior to me taking over. I'm sure you guys know the concept of grandfathered clauses. Assignment 1's been grandfathered into you guys. I can't dump it because there's no way I can get you ready for my version of assignment 1. But you guys will definitely be ready for my version of assignment 2.
How different is it? Like when you say we can't get ready, is it because of the naming conventions or?
Or you don't have 3 weeks of theory lecture.
Ah, that makes sense.
My assignment 1 is I handed out a fake invoice and some sample data, and I told them to design a database on that. No SQL. Literally pure, normalized, properly designed database with 14 tables or so in it. They had the theory lecturing for it. Yes?
Would it be possible to give us that as like an optional thing that you can just make it available to us and we can maybe look at it?
Later onwards, maybe.
Yeah. You guys can take a look at it going forward. And at least it'll give you guys an idea of what other kind of work, because that's very similar to the kind of work I did when I first got out of school. Like I said, I've been doing this for 20 years, and I've seen it all. So I tend to teach to the concept of how it's done out there, as opposed to how it's done in the schools. Okay, let's get the naming convention stuff out of the way, because mine are very strict, because for a few reasons. A lot of the textbooks haven't accepted the fact that there's starting to be a de facto naming standard that's slowly bubbling to the surface. When people first started working in the database industry years and years ago, people did whatever the heck they wanted with their naming. There's a few reasons for that. A, the servers were very limited. How many of you have watched a movie where they still have the tape-to-tape drive going on the computer? Okay? You know, those tapes held maybe 2 megabytes. Right? The picture coming out of your cell phone has more data in it than one of those tapes would hold. A few years later, the first hard drives came out. My first job, my co-op, they had a System 36 from IBM. The hard drive was this tall. It was huge, 14 megabytes. And when it died, you had to kick it. Someone would get it started again because they didn't make them anymore. You just stop spinning, you give it a kick, and start spinning again because the bearings were finished. So what happened is the naming conventions were really restricted back then. So people got used to these weird name things, right? F, N, N, E. First name, something weird like that. Actually, that was a horrible version. Let's try that again. F, N, E. That'd be your first name. Why? Because they didn't have a lot of room to work with. So when you look at the examples in that textbook, or some of the assignments that were created for you guys prior, you'll notice these weird mixed cap, abridged field names. Now, about 8 years ago, 7 years ago, 8 years ago, I'm getting old. Have you heard about Ruby on Rails?
Yes.
Right? I'll get some nods, right? Ruby on Rails. Ruby on Rails was great. Not because Ruby was great. As a language, Ruby sucks. What they had was innovative was Rails. Rails was a framework. If you created your database following their rules, Ruby knew what the database did. It understood the structure of that database if you followed the naming conventions. So all the other software companies that wrote languages like PHP, let's ignore Java, because they still do things wherever they want, because they're Oracle. Python, Perl, even Microsoft. Some of the they said, this is a great idea, this Rails thing, let's make our own. And they did. And after a little while, they said, you know what would be really cool if we all started working together to come up with a fairly common naming convention. So suddenly the Rails naming convention became the convention, almost. There's basically 2 conventions out there. I use one. There's another. And then there's the legacy conventions, is what you guys have been working with so far. The conventions are as follows. lowercase everything, and yes, I wrote that in uppercase. My handwriting is so horrible I can only print uppercase. Otherwise, you won't be able to read it. Lowercase everything. No spaces, obviously. That's like shooting yourself in the foot. By now, you guys have learned that in SQL, the keyword delimiter is a space. Therefore, there's a reason why you don't use spaces as in your object names. Otherwise, you have to use identification markers. And depending on the server, they do it differently. Okay. I even highlighted that in a different color. Table names are plural, always. Why? This table holds users. This table holds invoices. This table holds RPG statistics. Table names are plural because they hold many things. Obviously, field names are singular, are also known as attributes. Entity attributes are singular. Very rarely do you have a reason to make it plural. There's the odd case, but there's no reason to make it plural. It should always be first name, given name, date of birth. I don't know if you've ever seen anybody with more than one date of birth, but normally a singular date of birth will do the job. Okay. Foreign key names, which I don't know if you know what those are. Foreign key names are singular. You know the way they've set up this room, I have like no whiteboard space at all.
You can, if you're not presenting anything, you can.
Yeah, I know,
those
but
up, yeah.
I also want to make sure it gets recorded. So I've got till here. So I'm going to get rid of this, just for a minute. Okay, this one's long. Foreign key names are a singular parent table name underscore primary key. I'm actually going to do some examples on the board in a moment, so you have a visual example of what I'm referring to. The last little bit is the name of your primary key. Have they taught you what the primary key should be called in a modern database? I'm not talking something from 10 years ago or 20 years ago. Modern database. Yes, just straight up ID. Your PK, at least as far as I'm concerned, should be always called ID. All right, so now I'm going to do the example. Actually, I'm going to wait till you guys are done furiously scribbling, and then I'm going to...
What do you mean by underscore?
Yeah, underscore out. That's what I'm going to draw
Okay,
it up
you're
on the
gonna
board.
show, okay.
I'm just giving you guys a chance to catch up to my writing, because I'm going to need... So, I'm going to create a table. Table also known as an entity, right? My table will be called users. Now, is that actually being caught by the camera? Hot damn it is. Okay, I have users. I'm missing a marker. My board writing is very colorful. Okay, I'm going to create my primary key. Actually, that's supposed to be lowercase. Come on, Dan. Okay. ID. This is our PK. All right. In most systems, this is usually a number. In modern designs, like if you're going to be using a framework targeting struts, or you're targeting Cake PHP, you're targeting Rails or Laravel, take your pick your framework. It's ID. Now, number, it's usually an integer of some sort. Why? 1, 2, 3, 4 is easy to find. Yeah.
Can you use a different marker?
Of course I can. Because you can't see the line green at the back. That better?
Yes, thank you.
Okay. Okay, so primary keys are called ID. End of story. Do not pass go. Do not collect $200. Anything else but that, when you get one of my later assignments or my new labs, this is what you're going to be looking at. All right. Okay. Lowercase field name, data type, varchar. I will need to teach you guys about the difference in data types, apparently. And let's just say I've got another table called user types. Pretend there's another table here called user types. My hand can't keep up with my brain. Okay, there's a pretend table over here called user types. The foreign key would look something like this. Really like writing uppercase. User underscore type ID. So that's what this meant right here. Singular parent table name. Okay, the parent table name like that. So that's the naming convention. Underscore, if this had a primary key called ID, which it's supposed to be, at least as far as I'm concerned, then it's the singular version of the parent table name underscore ID. And this actually gives a bit of logic, right? This is the ID of a single user type. Where do you find the user type? In user types, because that's where the bin of user types are. Now, as a rule of thumb, there's always exceptions to the rule, especially in the English language. Why? Because the English language is stupid. As we know, there's words that are always pluralized. And then there's words that assume plurality. For example, user log. It's the word log assumes multiple entries by default. User logs is kind of weird. Just like horse. It's not horses, it's horse. Words that are always plural by default, or never don't have a plural form, will obviously not be pluralized in your table name. That's just how it is. And then there's people trying to avoid situations, right? Where you have people versus persons. You know, some people use the table called people, other people use the word persons. Technically, it's the same thing. And you can pluralize the word person, just so you know.
Persons, yeah.
Persons is completely allowed. So for designs, persons is allowed. Okay. Yeah, this room's a little odd. This was my classroom last year. We didn't have 2 screens. We had this screen. So they added a second screen. For whatever reason.
So do you mean a foreign key should be parent table name underscore primary key? Like
Yeah.
that's the format of it?
Yeah, that's the format that I'm using.
Would it be correct to assume that any new table you create, first field that you should generate is an ID field?
Yes, and in actual fact, let me go past that just a little bit further. The guys are learning Java, theoretically. Don't know who's teaching you Java, but
Howard.
oh, good.
We'll mix it.
It's a
You don't have
mix.
to teach us that too.
Eh?
You don't have to take over that class.
I used Java 14 years ago to write a Java applet for a web page. It was 22 lines long, and I never touched Java since. On the other hand, I've got an application I wrote in PHP that's sitting at 47,000 lines of code. So, you know, my skills are elsewhere. Java's not. There's a bit of a reason for this. And also you'll notice that I call this name, not username or description. That one's actually optional how you choose to follow this. But if you happen to have all your tables, excuse me, following the same naming convention, there's a little piece of magic that happens for the developers. They don't need to guess what the primary key is called. You can actually write a class that retrieves a record in Java, and all you need to do is pass in a number. And then, because you're always following the same naming convention for all your primary keys, you don't need to add a second parameter. So instead of having, function get record, parameter 1 being the field name, parameter 2 being, whatever the value is, you just go retrieve record ID, and bang. The code, the developer knows what to expect. Whereas when you have this randomly changing, student no, employee no, number, or you'll have lesson num, or just lesson ID. And when it changes every time, the developers actually have to know the underlying table structure. Whereas if they are using this convention, they don't need to know. They can just go select star from where ID is pi. And bang, they get data back and they don't need to guess because they know. The power of naming conventions. I've been told by other profs I'm anal retentive about them. But you know the difference between me and them? I've been doing this for 20 years in the real world. Okay. This. Hot damn, it worked. Okay. Obviously, this is not week 2. But it's the same slide you'll see in the video for week 2. But instead of taking an hour and a half to cover, I'm going to cover it in 20 minutes. Why? Because I want you to watch the video. Okay. I'm going to cover the basics of database design in this one. Types of tables, types of relations, basic parts of an ER diagram, the basic parts of the tables, and naming conventions, which I already did. Actually, I think I did it in more detail than I did in my other class. All right. Tables and entities are the same thing. So if you hear me use the word entity or use the word table, do an in-break substitution for each other. There's 2 kinds that you'll find out there. And this, believe it or not, is not something that's in the textbook. It's not something that normally is taught. Or at least it wasn't taught until I decided to teach it. But there's 2 common kinds. There's something called a reference table. Well, let me go kill the light. I don't know what screen to stand in front of. So there's 2 kinds, reference tables and regular tables. Reference tables are used to hold static data. How many of you have done an online web registration of some sort in the last month? Hopefully most of you, right? And you've hit a spot where you pull down state, province, country, current status of blah, 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 insert whatever it is here. Those are coming from reference tables. They hold a finite list. The purpose of them is twofold. One is to control data entry. Purpose number two is to serve as parents to regular tables. A reference table usually has anywhere from 2 to 4 fields. And the list of fields is actually pretty short. Because, well, it's gotten short. But if it has 2 fields, what do you think the first field would be? Right off the top. There we go. Believe it or not, that usually takes longer to get that one out of the door. The second field is what's called a descriptor field. Depending on what framework you're using or where you work, this may have one of multiple names. It is sometimes called name or description. Those are the 2 common names you'd get for the descriptor field. What purpose is it? In here, let's say we're talking about a table that holds names of states and provinces. That would hold Ontario, Massachusetts, Queensland. That's the description that points to that ID. So when you do the pull down, that's what shows up in there. But if you actually, anybody here look at the HTML of a web page, see what was in there? You'll notice when there's a drop down that normally there's a value, and next to that there's actually submitted, which is a series of numbers. That series of numbers is actually the ID of the table. Now I said there's 2 to 4 fields. These are the 2 you'll always find. There's one more that's kind of handy. It's called active. For example, you got a list of countries, and every once in a while, as we know, in other parts of the world, countries change names. Countries break up into multiple countries, such as Yugoslavia became 3 or 4 countries, depending on who you ask. I used to work with Yugoslavian while the whole country was falling apart. Every day he was watching the news, trying to figure out where he used to live, because part of the cities changed names. So active, that allows you to turn off a record. So you have a field called active. Normally, it's a Boolean, true, false. That means that let's say we had a country called Yugoslavia, and we have people that are registered on our server with a country called Yugoslavia, so we have their data in the database. That country no longer exists. However, we have data that refers to that country, but we don't want to make it an option anymore to be selected going forward. So if we make it active false, and then we build a query to pull that data saying where active is true, we can ignore countries that are now defunct, provide a clean list, but we don't lose any data. Thus, active. There's another pair of fields that you might see. Created and modified. I'll give you 3 guesses what the purpose of those 2 fields are. Considering their date times, or timestamp, depending on the database server. Basically, for when was this data created? And I'll put you into a little secret. I'm about to talk about regular tables. How many of these fields do you think apply to a regular record, to a regular table? All of them. So as a rule of thumb, when you start designing a new table, do those 5. Poof, done. There's your template. Good to go. Therefore, if you start designing and use these 5 fields as your first 5 fields in every table you ever design, you've covered yourself 3 ways from tomorrow. You're keeping track of whether or not it's active, whether or not it's got a name, when was it created, when was it last modified. Sometimes you'll see a few other things thrown on this, but that's what it is. It contains the standard data. For example, information about all of you, right? Students. What would you find in the students table? Your name, your identification number, your student number, your other identification number, which depending on where you're from, could be your SSN, your SIN number, your NIN number, If you're an exchange student, it's probably either your visa number or your passport number. Your date of birth, your current address, your phone number. That is regular information that goes into a table. That's a regular data table. So if you hear me talk about a regular table, that's what I'm talking about. It's a table that holds lots of information and that certain things might be pulled from another table. Just regular data, regular, everyday, ordinary data. And it can be either a parent or a child, or a child. In a bit, I'll cover why or where that comes in. All right, attributes, also known as fields. An attribute, it's a property or a characteristic of an entity of a relationship type. Just don't pay attention to the word relationship type for now. The important word on there is of an entity. What's another word of an entity for an entity? A table or an object, depending on what you're working with. Those are attribute properties. In other words, a person's name, their date of birth, those are attributes of the entity that is you. If I were to represent that in that database, it's a field or a column, depending which database system you're using, of a table. There's a few classifications that goes with these. Required versus optional. What do you use for required or not required?
Primary key.
No, that's for the primary key. Null, not null. Right? If it's not null, it's required. If it's null, it's optional. Pretty straightforward concept. All right. Simple versus composite attributes. I hate those. A simple attribute, your date of birth. A composite attribute, your address. Why is an address a composite attribute? Anybody want to shout out? If you speak up enough, my camera will pick you up even.
Because it can change. Because it's got multiple parts, like street, town, province, country.
Is that what you're about to say? He took your glory from you? No? Okay. Don't feel bad. I make fun of everyone. Okay. Yes, it's made up of multiple pieces. In a properly designed database, you do not have composite attributes. You have broken it down to all its bits and pieces without going overboard. There's single valued versus multi-valued attributes. Single valued, your date of birth. Multi-valued, they basically get their values from a reference table. A province is a multi-valued attribute. In other words, this can have multiple values based on an alternate source. The textbook actually explains it a little bit differently. It covers about a paragraph on that multi-valued thing.
As opposed to a composite, which is basically one value with many sub-values?
Yes.
Kind of? Okay.
Yeah, this one here means it could be multiple values based on another source, which normally is, there's a single field with single value, but it can change based on what somebody else picks. Stored versus derived attributes. We store your date of birth. We can derive your age. Now minus date of birth equals how old you are. And literally, in most database servers, you can actually run that query. Select now minus, actually go, select now minus this colon interval days, and it'll actually return to you the number of days since the day you were born. There's all kinds of cute tricks you can do. And then there's identifier attributes. What's an identifier attribute? Your primary keys. And your foreign keys. Those are your identifiers. They identify things. All right. Here are model constructs. Entities, also known as tables. I'm sure you've all had so much fun trying to learn how to use Toad. It's definitely not the best piece of software out there. It's just that we had to come to an agreement between all the teachers, since we all use different tools. So we picked one that none of us had used. Well, it was made it fair, right? Actually, that's not true. I've used Toad before, but I'm not as experienced with it as I am with some other packages. So essentially, it has entities, entity types, relationships. Basically, what connects one table to another table. Did you guys learn anything about relationships? Maybe. So I have no idea. I'll be asking, have you learned about this?
One-to-one, one-to-many.
Yeah, one-to-one, one-to-many. Good. I don't need to go into too much detail.
Just assume no.
Well, I know, but
I mean, it's all confusing. That's the problem.
Yeah.
We have bits and pieces from here
No
and
one
there.
ever explained it properly.
okay. I will try to do my best to give you the abridged, and it's covered in more detail, obviously, in the full-size videos. Because I got to cover in 2 weeks, well, 3 weeks, what you guys have missed in a month, and still keep you up, right? So relationships, I'll be covering those in a bit, what those actually, the differences are. Attributes, those are your fields. Basically your date of birth, your name, that kind of stuff. All right, entities. This is a somewhat more detailed slide. An entity is a person, a place, or an object, an event, right? Concerts, concert goers, that kind of stuff. Entity types is a phrase that almost nobody uses, but it's in the textbook, so it's in the slide. Basically, it's a collection of entities that share common properties or characteristics. In other words, you are an entity. Your entity type is students, right? You are a student, that's your type. Because there's several of you in here that are students, I hope. And a single instance is you are a student, and you're a student. You're instances of the student entity type. This is all definitions. In other words, this is just a fancy way of saying it's a table that has a row of data that identifies you as a person. So we can pretend, for example, this room is a table. Now pretend I'm not in here for the moment, okay? This room is a table. Each of you is a row of data in this table. Therefore, each of you are an instance of an entity. The entity type that you are is student, and this room we pretend is a table called students. That is the physical explanation of how a table is. Does that make sense? Yes. All right. An entity should be, it's an object. In other words, if it physically exists, or it's something that has happened or can happen, if it's a thing, you know when they say this is a thing, then it's an entity. What it should not be is the person using the database server, which is actually a really misleading statement. That's actually straight from the textbook, believe it or not. And it's actually a really stupid statement because what happens if you have a table called users? But what they mean to refer to is not the person sitting physically at the desk, not whatever else. And then it should not be the output of it from the database. In other words, is it a report? Is it a data dump? Is it a web page? That is not what an entity should be. They show some examples here about some options. Essentially, these are field names, /attributes. They have data types. I don't know how much you've learned about data types, I'm going to assume nothing. Whether or not they're required and optional. Essentially, when you start designing a database, you want to create something that looks like this. I have a big honking whiteboard in my office, and I tend to spend my days drawing when I'm working things through. And I'll basically use different colors for each of these things, but I'll put in the parts that describe it, whether that's required, what kind of data type we should use, that kind of stuff. If you want me to stop and explain anything, please speak out. All right, simple versus composite. Here we go. Actually, he explained it so well that he basically worded this whole slide. You'd swear he's watched my other lecture. But essentially, an address is a composite data type. In other words, it's made up of smaller pieces. You should never have a composite attribute in your database. So in other words, you create a customer record and you go customer ID, customer name, customer address, and that whole field is the address, you deserve to be shot. For two reasons. One, it's impossible to search. For example, you want to find everybody who lives on Cobden Street, but you have a composite attribute where this town, Cobden's also in there. So you do a good old select star from customers where address like %, Cobden, %, it'll give you anybody who lives on Cobden Street, anybody who's got Cobden as their town. Maybe we have the word Cobden as part of a building name. You'll get all those people. Thus, the search is useless. If you're trying to find, Cobden has a population of what, 1,000? So you're trying to find everybody in Cobden, 1,000 people, but you also have the 500 people that live on Cobden Road, Cobden Street up the road there by the zoo. That strip there, you get all of them. How many Cobden Streets do you think there are in Canada? You get all those people too. Did you know there's more than one Cobden town? So therefore you couldn't search for by province because it's all Cobden. Don't do this. But when they talk about a composite attribute, that's what they're referring to is that bit. Take that, all those pieces, break it down to separate entity attributes. In other words, separate fields for each one of these, and you're going to be golden. Life will be good. All right. Now, here they're referring to derived in multi-value. And in this case, they're referring to a field that has one or more possible values. And it could either be A coming from another table or B being referred to from another table. It's so dumb, but it's how it is. And I'll explain to you guys how to handle that properly in a few minutes. And then you got the derived attribute, years employed. If it can be calculated, as a rule of thumb, don't store it. Unless you're dealing with huge amounts of data. For historical purposes. For example, years employed, in this case, is fine, you calculate it every single time. But if you are talking about orders, you don't want to calculate the extended total, quantity times price minus discount is your extended price. You don't want to calculate that every time. If you're a small shop, like as in, you might get 500 orders a day, go ahead and calculate it every time. If you're Amazon, no. Don't do that to yourself. Don't do that to the database servers. They will hate you.
Because it would have to calculate everything and store it every single time.
Yeah, but it doesn't store it. When it's derived, it's not stored. It's calculated every single time.
Okay.
So therefore, it's all this overhead being added to the query. Even though the query is really, really fast doing this math, you might be adding 1/1,000,000th of a second to the transaction. What the heck's a millionth of a second, right? It's not even the time it takes to blink. Now, look at the volume of data that pushes through Amazon in a given second. You know that 1/1,000,000th of a second will suddenly become seconds, and then those seconds cause snowball into minutes. Do you guys ever have a checkout from Amazon that took more than 5 seconds? Literally? No? I mean, you hit press this credit card, gone. Instant. Why? Because they're storing all the data and it's processed. And the system doesn't need to keep calculating this every single time you look at it. Most of our systems where I work, we calculate everything. Why? Our volumes aren't that big. I think our biggest table has 1.5 million rows of data in it. That's the biggest. So that's not saying much.
That's small.
By Amazon standards, it's small. By the standards of a company of about 50 employees, it's big. Right? It's matters of scale.
Can you not, if you have to calculate something, can you not store it? Does it have to be, does it fall under derived?
This is where the concept of denormalization comes in, which is a topic for a bit later. But that's where the concept comes in, is you store it when there starts being performance issues. If it's not a performance issue right now, as in, if that millionth of a second does not affect anything, as in,
keep it derived.
If you're only getting a request for an order every 10 minutes, what's a millionth of a second in 10 minutes? But if you're getting 1 million requests every minute, that millionth of a second adds up pretty fast. It's just overhead. It causes everything to snowball. Okay, Identifiers, also known as primary keys. What's the purpose of a primary key? Unique identification of an instance, of an entity type. In other words, everybody here has a student number. As far as the school is concerned, that's your primary key. Congratulations, you all have a primary key. If you're a Canadian citizen, you probably have a SIN number. As far as the Canadian government is concerned, that's your primary key. If you're a foreign exchange student, then you have multiple primary keys. Therefore, you end up with a composite key. A couple of different ways to identify you. So a single row identifies, the key identifies a single row, so you can pull it out. Simple versus composite, in other words, simple, a single is this, one field called ID, or called whatever, but one. A composite is if you have multiple fields that make up a primary key. In other words, for some unknown reason, you have name and date of birth as your primary key. Why on earth would you do that? I have no idea. But, theoretically, you could do that and make that as your unique record identifier. And as a rule of thumb, never use a person's name and their date of birth as their primary key, because I've experienced it. Somebody almost stole my identity because he actually had the same name and the same date of birth as me, but he lived in New Brunswick. And his SIN number was only 2 digits different from me. It was fantastic. I had to explain a lot of things to my credit bureau on a regular basis. He's not very good with his money. So, as a rule of thumb, use single keys. Why? You don't have to deal with the whole kettle of fish of what happens if this combination suddenly doesn't work. Then you have to find a third piece, and then your key gets huge. So instead of going select star from users where ID is equal to 5, you end up going with select star from users where name is equal to Dan, and user ID is Dan G, and. So it becomes more difficult to retrieve data, and it makes the programming harder. Candidate identifiers. So when you're first starting to create a database, you might look at the data and go, so many of these things can be unique identifiers. Student number, SIN number, NIN number if you're in the UK, SSN if you're in the States. These are all things that could be used to identify you uniquely. So what the candidate keys are, what are the fields that could be used to uniquely identify something? Those are what's called candidate keys. But as a rule of thumb, if you design all your tables with a single field primary key, well, you solved that problem now, didn't you? Right off the bat, problem solved. Okay, but if you need to use something other than ID because maybe you got a job with the government and you have to deal with one of their old COBOL databases, hey, it works. You laugh. You graduate from college with one course in COBOL and you get a $90,000 a year job. Guaranteed pretty much for as long as the government stands. People laugh. I hear people laugh about COBOL all the time. Dude, they make more than I do. And it still works. If it works, why change it? All right, identifiers. If you have to use something other than ID field, pick something that's not going to change. It cannot be null. For example, your date of birth. Unless you're a clone or an alien, you have a date of birth. Avoid what they call intelligent identifiers. For example, a location. Okay, primary key, Dan Goudreau, Ottawa. A week from now I move out to, I don't know where, Gatineau. I don't know why I do it, but let's say I move to Gatineau. And suddenly, part of my primary key changed. Thus, it's not a valid primary key. Use simple keys instead of composite keys. All right, when you're defining attributes, state what the attribute is and probably why it's important. In other words, when you're doing the initial design, you look at all the little bits and pieces that make up a person. Why is your name important? Some people are really offended if I make fun of their name. I don't know why. Some people don't think it's important. But why is it important? Why is your date of birth important? It's important to know when your case day is. If you have to change the name of something for some unknown reason, by that I mean, instead of using the word date of birth, you use DOB. For some unknown reason, you decide to use the short version. Document it. Why you're using shortcuts and aliases and alternate names for something. Depending on where you are in the world. In Canada, we use first name, last name. In other parts of the world, it's first name, family name, given name, family name. Document why you call things the way they do.
Where do you document all this?
Usually a document. Where? It depends where you work.
No, you need to have like a file attached to your...
Well, normally most database design tools have the ability to put comments on everything. As a rule of thumb, as you guys look, when I, like whoever asked over there for me to post my first assignment for the other group, I think it was just over there, you'll see the kind of document that I used to have to work with when I first started out. Actually, I'm making them do an exercise I had to do essentially in college, right down to the tedious paperwork that went with it. And you actually keep track of why you choose to do things. Like obvious things, like if you call a field called date of birth, I think you don't need to document why it's called that. But if you call it DOB, believe it or not everybody understands what DOB means. So if you're going to use an alias, an alternate name for something, document. All right, state source of values. In other words, is it a value that's user entered? Is it a value that comes from somewhere else in the database? That kind of stuff. Whether or not the attribute can change. Sometimes things are immutable. Your date of birth should not change. Your name can change. You can just go write a little piece of paper, $75, and your name changed. Your gender can change. All kinds of things can change. Specify whether it's required or optional. In other words, is it null or null? Min-max values. In other words, minimum date of birth, maximum date of birth. Maximum number of cats you're allowed to have.
Infinite.
Eh? Infinite cat. Yeah. Indicate relationships to other attributes. In other words, if you have one entity, users, you have another entity called user types, identify that there's a relationship between the two. And normally you want the document, users has many users. We go to something like this. Users belongs to user types. Or if you want to be the kind of person that goes the other way around, user types has many users, depending on how you just want to do it. In other words, you should be able to explain what the connections are with very few words. Pictures are worth 1,000 words.
So what this says is that a user type can have many users, but a user will only have a single user type.
Yes. That's exactly what that says.
Okay, can you repeat that, sorry?
User types can have many users. My CrossFit skills are just beyond, There. Users can have one user type. User types can have many users. Which leads me to types of relationships. And here they are. Okay, they have what they call RI relationships, referential integrity relations. One to many. In other words, there's one value and many child values. A customer can have many orders. An order can only be placed by one customer. Many to one. And this is where you can have parent, 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 right? A customer has many orders. Each order can have many order items. When was the last time somebody went to the store and they bought, actually that's a stupid example. How many times you go to the store and you buy more than one thing?
Most of
Almost most of the time, right? It's rare you go in to buy the one thing, except like Best Buy. And then if you're buying more than one thing, you probably have issues with your wallet. But essentially, a one-to-many, a parent table has many children. It involves a primary key, in other words, an ID, and a foreign key. The foreign key is found in the child. The primary key is in the parent. P is for parent, P is for primary key.
Is
foreign key is for frickin' child. That's the only I can't make F work with child. So frickin' child. I have kids. Yes.
Is that how you define like parent and child with keys?
Yes, the parent normally. It's possible to have relationships without using the primary and the foreign key. Using a primary key, it's not a good idea. So normally it involves a primary key in the parent and a foreign key in the child. Okay, there's one-to-one. One table connects to another table, and there's only allowed to be one record in each that are related to each other. Not commonly used. Just saying, it's not something you see every day. It is used often for security purposes. You have a customer table, and you have another table that hangs off the side that have other information, such as credit card information or safety, security type stuff. Therefore, you can use the database server security to lock people out of those tables so they can't see them unless you have the appropriate permissions to see that table. They used to be used years ago when database servers were very limited. Now, in this crowd, I'm guessing maybe 3 of you are old enough to remember something called DBase. In DBase, you had a limit of 100 fields per table. If you needed more than 100 fields, you created a second table with a one-to-one relationship, and it just kept growing on and on to the end. That's what I cut my teeth on, by the way. I'm not aging myself at all. Not much. And then next one we have is many-to-many. So we have a relationship that is many-to-many. And if you want to think about it, students to teachers, right? Each teacher has many students, and usually most students have many teachers. So you have this web of connections between the two piles. And sometimes you end up with connections like Howard, where you have them for 2 classes, database and programming. So you end up with many, many relationships. That's an example of a many-to-many. This is being used less and less. Many-to-many, like the concept of many-to-many still exists, but the direct connection business is frowned upon in modern design. Why? It's entirely possible to go and delete a single student, and if you had the cascading, now let's go delete a single teacher. And there's a cascading effect that happens. Delete the teacher, delete all the students. Oh, that student's related to a teacher, delete all those teachers. Back and forth until suddenly your table's empty. And I've seen that happen.
It does it on its own?
If you have cascading rules created on the server, it will cascade and delete everything. It's like the difference between using a sniper rifle and a nuclear bomb. Everything's gone. Many-to-many don't do that. Something's come in called a has and belongs to many table setup. There's another word for that, and it's later in the slides. I'm drawing a blank on the moment. The textbook calls it something different. Modern database frameworks call it has and belongs to many. Habitum. And once was a time this would been done like this. Something like that, right? Straight across. And then you end up with the cascade delete of doom. So nowadays, though, what people will tend to do is have a has and belongs to many table, or a linking table, has many names. You'd call something like Heck, where's that? Actually, I called it props. And then you have something that goes like this. Like such. So that means that a student can have many entries in student profs. A prof can have many students, many entries in student profs. But
Never happened.
no, I'm not supposed to say that. Never happens. But in here, what I could theoretically do is just delete those rows with and replace them with a separate set of rows without causing a big cascade effect. Yes.
You said something about turning on cascade effect or something?
Cascading. Different database servers support and some don't. Cascade is a referential integrity rule. So when you create a foreign key, you can actually say on delete cascade. And that means that when you delete a record, it takes up the child records with it.
Oh, so you don't have to go and delete each little thing by itself?
Well, normally when you got RI, you can't delete the parent until you've killed off the children. Otherwise, it's called having orphans. And having orphans sucks. Sorry for any orphans. I probably offended at least 3 people on that one. But that's why cascade rules exist. You delete the student, it takes out all the entries for student profs without nuking the prof.
That's like deleting a folder of classes.
Yeah, it's like deleting part of it, yes.
That would be useful for purging old data records.
Yeah, exactly. If your database is designed like this, it's fantastic. If it's not designed like this, it becomes harder.
For you to delete something, can you not replace a term, or do you have to delete it and then redo it?
Well, it depends, right? In this case, if you're replacing one prof with another prof, you can just run an update on this table.
Okay, so say change John to Dennis or something.
Yeah. But that having been said, that's what this allows you to do. Instead of having to do a weird round of cascading updates over here, where you update this one, they have to update that, and update this, and update that. You can just take care of it in the middle table.
Is the middle table an associative entity?
Yes.
Okay.
You read your textbook?
Well, that was a question for the labs or something.
Yeah, that's exactly what thanks, because I remember I was saying I couldn't remember, I was drawing a blank. It's an associative entity. That's the official term for it. Everybody who actually works out in the world nowadays calls it a has and belongs to many table. But has and belongs to many is the same thing as an associative. Thanks.
Okay.
Your brain's tired. So do this. Logical relationships. That's not covered in the textbook. Just saying. This is when I was taught database a few years ago, 20 some odd years ago, we were taught this concept as well as this. Okay, a singlet. A singlet's a standard standalone table. For some unknown reason, there's this table floating that's not connected to anything. For example, settings. Logs, just log files, log entries. No connections to anything, just pure data being dumped into it. Parent-child. It's a parent table that has many children. Usually connected via primary key and foreign key. Often, it's a reference table pointing to a regular table. User types points, which is a reference table, it's pointing to users. That's a parent-child. Master detail is a superset of parent-child. It's 2 regular tables.
Sorry, can you repeat parent-child once more?
Parent-child means there's one table that has many records connected to it by another table.
Okay, so like this, but many more.
No, like this one here. Can't see behind the screen, but they have user types and users.
Yeah.
User types is the parent, users is the child. User types can have many users, but a user can only be one user type. Right? Your mother can have many children.
You can only have one mother.
You should only have one mother. Unless you're a clone. Then you're called Dolly.
Then I'm a sheep.
That's a sheep. Now, master detail is a superset of parent-child. It's two regular tables arranged in a parent-child relationship, such as a customer has many orders. An order can have many order items, right? So you got customers is a regular table, right? Because it contains all kinds of information. Customer, credit terms, address, shipping address, that kind of stuff. Orders have when was it placed, who was it placed to, who placed the order, has it been shipped, how was it shipped? And then you got the order lines. What did he buy? How much of it? How much did he pay per unit? Was there a discount? What taxes have been applied? That's a master detail. In other words, you've got our table has a lot of details, and it's a parent of another table has a lot of detail. That's known as master detail. The most common is in business systems. Orders, invoices, accounting.
What would the difference between parent-child and master detail be? Just the number of
No,
entries?
the master detail is a superset of parent-child. In other words, you have a parent-child relationship, but the entities are a little more complex than, for example, orders. An orders could have a salesperson as a parent, a customer as a parent, shipping term, shipping company, payment term, right? Those are all parents of orders. But at the same time, orders is a parent of order items because you bought many things. And order items can be made up of a product code, a tax rate, discount code of some sort. It's made up of other attributes, also of other related attributes. That's master detail. Parent-child is usually straight up reference table to another table. In other words, basically you got one feeding into another. But essentially, parent-child master detail is the same thing, it's just the scope of it's a little bigger. All right, degree of relationships. I am not going to spend a lot of time on that. It's just verbiage that when they were writing the book, they needed to reach a certain number of words. I kid you not. That's why I hate textbooks. Okay, unary. It's an entity related to itself. It's usually used for making trees. How many of you remember Yahoo? The old Yahoo? Right? The old thing where you click on a category, then it gives you another list of categories, you click on that, brings you another list of categories? Or Two Cows was another example. I'm pulling up old websites here because modern websites don't look like this, so it's really hard to visualize. But you got these old websites, and basically you had a tree of categories. And using a single table, you can build an entire category tree by making one thing related to another. It's just, so for example, we have an instance called a person. I'm not going to go through this, I'm going to go person, right? It's a self-referring entity, person. You're an instance. You have a relationship to your mother. Your mother has a relationship to her mother. Her mother has a relationship to her mother. It's all one entity called person, but they have self-referencing because you keep referring to another person in the same table. It's just, there's a parent.
Is that like a family tree?
Well, sort of, if you were to branch it out sideways. Once you have, you have two kids referring to the same mother, so now you've got a tree. But it's just the concept, it's still referring to itself. Binary, two entities connected to each other. User types, users. Okay, that's a binary relationship. Then you've got ternary and quadry and whatever the hell it is, where you have orders. Orders is made out of customers, shipping terms, shipping company, right? That's a four-way relationship because there's four entities involved. Normally, so what would happen is you have customers and maybe you have shipping addresses and they combine into a third entity called orders. That's a ternary relationship. Okay, cardinality.
Sorry, one question. When you say instance in the unary, what do you mean by instance?
You're an instance. Your mother's an instance. Her mother's an instance. Savage. Well, no, it's. I mean, if you ask the question, so I'm going to use you as the example. That's what happens in my class. Don't take it personally. It's the only way to keep database topics interesting is to tease the students. But at least you're going to remember.
I will remember that.
Right? And then everybody's going to remember because we laughed at you. Right? So, that having been said.
And everybody will get their turn.
Hey?
And everybody will get their turn.
Exactly. Everybody's going to get their turn. So that's an instance is each. So if we talk about person, a table called persons. You are an instance of a person. Your mother is an instance of a person. The relationship is an instance, relation between your instance and her instance.
So person is like the name of the table, and everyone comes
Everyone,
under that
there's an
table.
instance of a
And
person.
then they have. Okay.
Yeah, you can replace in your brain, you hear the word instance, put in the word row. Instance / row is the same thing. The joy of database design. When you're talking about the theory, they use words like instance, entities, and attributes. When you deal with the physical side, it's a table, a field, and a row. They're just words that mean the same thing. It's just it's a different part of the diagram. Okay. Cardinality relationship. One-to-one. In other words, there can be only one connection between two instances of two separate entities. I really have a hard time finding an example for that, so I usually tend to skip it. One-to-many. Your mother can have many kids. You can have one mother.
Amazon books.
Yeah. Well, that's still not a one-to-one because they can sell you multiple copies of the book, multiple copies, right?
The listing would be one-to-one. Here's the listing for the book, here's the PDF on the book.
Oh, yes, unless you're buying from the States, then it's a different PDF. There's almost never a one-to-one. It's very rare. The only time you get is like I said in DBase where you had 100 fields and you need 105, you have a one-to-one. You can't have this one unless you've got this one. One-to-many, already went through that. Many-to-many, again, you can have many teachers and teachers can have many students. That's the cardinality. It's the crow's foot, what I was drawing here. Okay, there's a relationship. That means many. That means one. And then earlier we had the cardinality constraint comes next, which I'm going to draw on here. Minimum cardinality, which means it's optional. Usually drawn with an O, with a circle on your line. This is optional. In other words, your mother can choose to have kids or not. You don't get to choose your mother. Right? Or, this means required. That means one or more. It usually means one on this side. If we had, I should just go with one here. And if we did it over here instead of this, we had one or more. That's the diagramming, the instances. Yes?
What does it mean in the model where it has the crow's feet and the one?
It means that it is required. So if I were to create, your mother must have a child. That's what that means.
Okay.
Right? You can be a woman and not have a child, but if you have a child, you're a mother. Therefore, if you create a mother table that points to a child, it's required on both sides because you can't be a mother unless you have a child.
Okay.
You can't be a parent unless you have a kid. Well, at least in the database.
Okay.
But that's what that means. So if you do this, it means that over here, you've got a required parent, and over here, you have to have a child. That means when you create the parent, you immediately have to have a child. It's required that you have a child. Very few database designs use that. That's known as an identifying relationship.
Okay.
Not used very often. It's kind of a gross.
For optional, can you have like no values inputted? Is that
That's optional, means that you can have a parent table with nothing pointing to a child. Could be you just created your table, all new products, and none of those. You create 5 new products, but you haven't sold any yet. Therefore, the products exist without any child records and order items because nobody's ordered it yet.
But for something that's now not in production, you will have the second kind. Say, because
Yeah.
you obviously have sold something.
You have sold some, but it's possible that you didn't, therefore the relationship stays the same anyways. You don't change your relationship once the data evolves. You establish a relationship at the beginning and you follow those rules. Associative entities, I covered it already when I talked about has and belongs to many. So I'm going to skip that slide. Check constraints. Okay, we're almost finished this slide. Should I see if I'm fast and get through the next one? Check constraints are used for integrity. There's a couple different kinds. There's integrity constraints. Okay, they're used to make sure that the data going into the database follows certain rules. I'm not even sure where it's covered in the textbook if it is. But essentially, it ensures that a row matches a given rule, otherwise it can't be created. You can have multiple conditions. And it follows a format of column condition value. Hopefully by now you guys have learned the concept of conditions. Learned about if statements in Java yet? If I greater than 10? Yeah. It's the same idea in database. When you create a field, such as a price, you can force that the price is not allowed to be 0. So you create a new product, you can't create the product unless you give it a price. Therefore, price greater than 0. As long as the price is greater than 0, it can be entered into the database. That's called a check constraint. It makes sure that, how can I word this properly? As a database designer, don't trust the developers. I guarantee they're going to screw up the data. Why? Because that's what they do. I do both sides of the deal, and I script my data all the time. Because I don't use check constraints as much as I should. So essentially, you create a rule. Not all database servers support check constraints. For example, MySQL can't do them worth shit. In other words, it can't. Postgres, on the other hand, can have complex rules and all kinds of things. Depending on which database server you use, they have some abilities and some don't. Oracle has the ability to have check constraints. Microsoft SQL Server sort of has check constraints. They're just implemented a little differently. Okay, I covered the basic parts of the table already.
We'll figure out how to use them, right? Later onwards.
Yeah. Well, actually, I did it in one of my labs, so I'll be giving you guys the thing. You're getting the lab document, but it was part of one of my labs already. I covered this already. I already did that on the board. Well, there's my naming conventions. Covered that already. Slideshow done.
Break time?
We just see the size of the next one. That's all this. Okay, what I'm going to do is I'm going to cover about 5 slides from this, and then you can have your break. Right, data types, which leads still to the topic I was just talking about. Before that talks about the database design process, and it's not covered on the exam. Therefore, I'm going to skip it for now. If you want to know about that, look at the slideshow for week 3. The slides are self-explanatory. And or watch the video for week 3. Okay, data types. Slide number 1, the text types. There's car/character. It's a fixed length field, always occupies a defined space. This used to be the data type of choice for doing text-based fields. Why? Remember earlier I talked about the reel-to-reel bit? If it was defined to be 6 characters long, the computer knew exactly how many millimeters to move that piece of tape to get 6 characters. It always knew exactly physically how far to move the tape. So that's why you can see the tape go back and forth, right? Because it's reading chunks of data and it's actually moving the magnetic tape across the head. It was a great concept when we had very limited space, 1 or 2 megabytes for the entire database. Once we started having space, like 10 megabytes, 25 megabytes, so much room. Somebody said, hey, it'd be great to actually save ourselves a bit of disk space. So they created something called varchar, or character variant. Postgres calls it character variant, but it respects the word varchar. Essentially, it's a variable length string. You define it as varchar 50. It means it'll hold up to 50 characters plus 1 byte. That 1 byte is used as a terminator. In other words, if you store 5 characters, it'll store 5 bytes plus 1. So it'll actually store 6. As opposed to taking up space of 50, it uses 6. It uses a plus disk space. There once was a time character had a huge performance advantage over varchar. Nowadays, most servers, you create a field using character, it actually uses varchar instead. It just aliasing the two data types. Except for Oracle, there's almost no advantage to using character. Text, used to hold up huge amounts of data, massive amounts of data. The text data type in Postgres, I think it'll hold up to 3 terabytes of text. Basically, you're limited how much disk space you have and what the maximum block allocation of your file system is. In other words, if you have an old computer running like the old file system, the old fat file system, your limit was a 4 gigabyte file. Windows N, the Windows NT and up, which is Windows 10, Windows 8, Windows XP, Windows Vista, Windows NT, Windows 2000, you could have files in up to 25 gigabytes. That's theoretically the maximum size your field could hold. Modern file systems don't really have a limit. MySQL has 3 different data types because MySQL is stupid. Everybody else has 1. It's called text, memo, or Oracle because it's special. It's called CLOB, CLOB, character large object, because it's Oracle. Okay, part 2, numbers. Integers. You guys know what integers are, I hope?
Yes.
Whole numbers. The numbers on here are the ones in Postgres, just so you know. That's the biggest number a Postgres integer can hold, both positive and negative. MySQL allows you to create an integer that is unsigned. That means that it never has a plus minus, which actually allows it to have 1 more byte for a number. So it can actually add a 9 to this, essentially. It'll add 1 more number. Decimal and numeric, they mean the same thing. Essentially, 131,000 digits before the decimal point and up to 16,000 digits after the decimal point. Absolutely insane precision. Unless you're talking about real or double precision, then you're talking about 15 decimal digit precision, and I think that's actually a typo. It's 15 byte decimal precision. Just so you know, that's
A lot.
huge. Yeah, you could calculate the grains of sand on Earth and still fit it in that field. Serial and big serial. That's a Postgres exclusive. 4 and 8 bytes. It's what's known as a metadata type. It's a data type that does multiple things at once. You create a table with a serial type in it. It'll create the field as an integer or an 8-bit integer in 98. At the same time, it creates something called a sequence. And then it assigns the default value of that field to the next value of that sequence. What is a sequence? Did you ever see those people sitting in the lawn chairs in the summer counting the cars going by? Yeah, usually you'll see them on Riverside and a few other intersections. They're sitting there with their parasols and go click, click, click every time a certain brand of car goes by, because they're counting how many brands of cars are going by. That's why there's 4 of them, because they're all counting different brands. That's what sequences do. They go click, 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 click. Each value can never be called out once. Non-repeat unless you reset the sequence. But that's what a serial is. It creates a field that automatically counts. MySQL's got something called auto increment instead. It's just an attribute of the field, and it just counts up. Microsoft has something called identity. It does the same thing. Oracle, you have to do it by hand. You have to do what Postgres creates as a serial. You got to do it by hand. You create an integer field. You create a trigger. You create a sequence. That's this 5-step process to do it, or Postgres does in one. Money. Not everything has money. But money is basically an integer plus 2 place precision. Considering most accounting systems actually go to 4 places, this is not so commonly used. People will use it, but you know, it's only if you're doing things that don't have weird decimal places, like the exchange rate, right? 1.3325. Why? Because all those pennies add up at the end of the year.
Some of the earliest computer programs.
Hey?
Some of the earliest computer programs.
Oh, rounding to my checking account. Timestamp with and without a time zone. Other database systems call this a date time. Different names, same thing. Postgres is insanely precise. It'll work in microsecond precision. A date will cover everything from 4700 BC to sometime after we're all long dead, 500,000 years into the future. I mean, 500 million years in the future. Time without time zone. In other words, it contains a time of day with 1 microsecond of precision. So if all you need to know is when something happened during a given date. And then it also stores interval. Intervals are special. It's not, the interval would be how much time has passed since the moment you were born and now. That is an interval, not the dates. How many seconds have passed?
Oh, it has to be in seconds.
Well, microseconds. But essentially, it'll take a number from, you know, that to the equivalent positive with microseconds of precision. So this is the number of seconds plus microsecond. Yeah. You know, consider, you know, 60 over here is a minute.
Yeah.
That's an hour.
So.
Yeah, it's a lot. Okay. We're going to take a quick break and we're going to come back to that pain.